Hello and welcome to lesson 10 for Math 13x. So using the z-score, so the formula for the z-score is, it's just from three numbers. So I make my z's look like this because otherwise my 2's and my z's look the same sometimes. So z equals, and you just take the score, that's x, and then minus the mean, and then divided by the standard deviation. And if you only know the sample information, it's the same. And in fact, the words are the same. You take the score minus the mean divided by the standard deviation. So this is for the whole population. This is for a sample. So the first one doesn't have a story, but there is a normal distribution. So that means that there's this bell-shaped curve like this, in which case the mean goes in the middle. So the mean, the average for everybody is 23. And then if a score is a 19, so then 19 would be over here, x equals 19. And then it's given that the standard deviation is 1.9. And for this, just do the z-score. So z equals, take the score of 19 minus the mean of 23, and then divide by the standard deviation, which is 1.9. And when I go to put this in the calculator, I'm definitely going to put parentheses around the numerator. So parentheses, 19 minus 23 gets divided by 1.9. And I got my parentheses in there, so the answer is a negative 2.105. Z equals negative 2.105. And then one other rule for the z-score is if it goes beyond a 2, it's unusual. It doesn't matter positive or negative, but if it goes beyond a 2, it's unusual. So that means that the score of 19 is unusual, and because I got a negative and because it's below average, it's actually unusually low. So a negative means below average, a positive means above average. Anytime it goes beyond 2, that's considered unusual. All right, the next one. So I just Googled up what's the average height of men in the United States, and Google said it's at 69.2, and the standard deviation is 2.8. So that's talking about the whole population. This is supposedly true. So then for heights, there is a normal distribution, and in the middle goes the mean. So the mean height equals 69.2, and that's in inches. And then this is the score x, but the thing is this is in feet and inches, so I need to change that to inches. So 6 feet tall, and then there's 12 inches in a foot, so multiply by 12, and then add the extra 2 inches from here. So 6 times 12 plus 2 means that person would be 74 inches tall. And that would actually be above average, so they would be over here somewhere. X equals 74 inches tall. And now do the z-score. So z equals the score that you're being asked about minus the mean divided by the standard deviation. And, as my red pen likes to say, make sure you use parentheses. So that is 74 minus 69.2 gets divided by 2.8, and that is a 1.714. And the rule for the z-score is if it goes over 2, it's unusual. Would this height be considered unusual? No. So this is not unusual since the z is not over 2. Okay, then find the z-score for a man that's 5'2". So the last one was 6'2", this one's 5'2". So like with the last one, this is in feet, so I do need to go 5 times 12 plus 2, and I believe that's going to equal 62. Let me see. 5 times 12 plus 2 is 62. So the graph would look almost the same. In the middle goes the mean, which Google said is 69.2 inches tall. And then this 62 would be below average, so this would be x equals 62. And now do the z-score. So z equals, the score is 62 minus the mean is 69.2, and then divided by the standard deviation, which is 2.8. And then my red pen wants to remind me, use parentheses. So paren. Did you know when there's only one of them, it's called paren, and when there's two of them, that's plural parentheses? And then divide by 2.8. And that would be unusual. So that is negative 2.571. So 62 inches is unusual because this went past a 2.0, unusually low. So it's pretty far below average for a man to be 5'2". It's not impossible, but it is sort of rare. Okay, then find the range of values that contain 95% of men's scores. So like I said, if it goes beyond 2, and whether it's positive or negative doesn't matter, then those are the cutoffs for being unusual. So if you look at the bell-shaped curve, and you got a z-score of 2, that, if you go beyond that, that's considered unusually tall. And over here, if you have a z-score of negative 2, that would be considered unusual. And then you can use the formula that x equals the mean plus z times the standard deviation to interpret what height is this. Just because the z equals 2, I don't know if that person's 6'10" or 6'1", what? So just use this little formula. So for this one, it's going to be x equals, the average is 69.2, and then plus, use the z, so 2 times 2.8. And before I use the calculator and finish, I'm going to do the same thing over here. So x equals the 69.2 plus, this one's going to be negative 2, times the 2.8. All right, now for this one on the right. So take 69.2 plus 2 times 2.8. So that means that if a man in the United States is taller than 74.8 inches, which is almost 6'3", 6'2.8", so almost 6'3", that would be unusually tall. And now I need to do the same thing with minus. And of course I could type it, it would not take very long, but if you just go up, you can highlight it and then get it back again, and then just back up and make this a minus. So on the other side, it's x equals 63.6 inches tall, which is what, 5'2", 5 foot 3.6. So in other words, 95% of men would be between those two. So if you shade all of this nice and red, that's 95% between this height and this height.